Last class, we discussed about the what is big data and what is Hadoop, why we are moving to big data, uh, and what are the different components in the Hadoop. We discussed about that thing. Okay, coming to Hadoop, what is Hadoop is? Hadoop is a open source software for storing the large volumes of data. At the same time, processing the large volumes of data. That is the main concept and main mode of the Hadoop. So Hadoop, we have the lot of components for the different uh, purposes or different activities. So main basic components, what are the components are there? We explained in last class. So next classes, I will go through the one by one what are the components. First, we will start with the basic components. Uh, in Hadoop, we have the two basic components. One is the HDFS. HDFS, we will use the storage side. If we want to, in Hadoop, if we want to store anything, means we need to talk about the HDFS only. If you want to store anything, any file or any image or any video, any kind of data, if you want to store, means we need to store in the HDFS. Um, what is HDF means? Hadoop Distributed File System. So if you store anything, it won't store in single machine. It will be stored in the distributed fashion. Suppose if I have the 1 GB file, if I stored into my cluster or my Hadoop cluster, so then it will be uh, stored as spread as a different machines. So how it will be stored means it will be split into different blocks, different pieces. It will be cut into different pieces and it will be spread across the different machines. So that pieces in Hadoop terminology we will call it as a blocks. So next slides I will explain how the blocks will be splitted and how will be spread, who will distribute to different machines. Next slides I will explain clearly. So here so main concept is data will be stored into distributed fashion and it will be distributed into different machines. So that is the main concept of the HDFS. Next slides I will tell what are the internal things will be there in HDFS. I will tell you. Next, coming to storage side HDFS, for processing, we will use the MapReduce. MapReduce is a kind of a programming language. It is a parallel processing, parallel computing language. So generally, if you want to, suppose if you have the 1 GB, same 1 GB file, if you want to execute any logic on that file, it will be if it is run in single machine, it will take some time. Instead of that one, same logic if you executed in different machines parallelly, it will be load will be very less and also we will get the result in the less time. So suppose if I have the 1 terabyte of data, so one machine it will be if you want to process one machine, it will be take lot of time. Instead of that, multiple machines involved parallelly, it will be less load will be there for the each machine and at the same time we can get the we can process the data within less time. So that is the main concept of this MapReduce. So first I will start with the Hadoop, then we will go through the how we can process the data. So first we will go through HDFS, how we can store the data. So Hadoop is the Hadoop will follow master-slave architecture. So only one master will be there and different slaves will be there. Single master will have the single name node. Next classes I will tell you the okay how many name nodes will be there. I will tell next slides. So first coming to here in master, we will have the single name node, secondary name node and job tracker. and each slave we will have the data node and task tracker. What are these name node and data node are? These are the daemon processes or services. So Hadoop is developed in Java. So once if we started Java, if we started the Hadoop, we will backend we will some process will run. Those process will call it as a daemon processor. So these are the Java services or Java programs. So HDFS side we will have the name node, secondary name node, and data node. MapReduce side we will have the job tracker and task tracker. So in master we will have the name node, secondary name node, and job tracker. Each slave we will have the data node and task tracker. So generally, if in production systems, if name node will be in master and secondary name node will be in some other machine, job tracker will be in some other machine. But coming to now, while we will starting, what we need to remember is in master node we will have the name node, secondary node, and job tracker. Next to if I talk about production systems, or if I talk about multi-node cluster, then I will tell clearly about the job tracker and task tracker where it will be there. But till now, present you can remember as a name node and secondary name node, job tracker. It will be run in master, and the data node and task tracker it will be in slave node. So coming to name node, why the name node means? Name node will have the meta information about the data. So previously I told if you store anything in the HDFS, data will be split as a blocks, and it will be spread into different machines. So who will maintain these information? Which file will be in which machine? That information it will be in name node. So name node generally name node won't have the data node. Generally name node won't have the data. It will only having the it will only maintain the metadata of the file system. This HDFS file system. So here one thing is next I will tell we have the different modes. Next I will tell. So suppose if you install the Hadoop in single machine, then everything master will be same, slave will be same, everything it will be in one machine. But if you if you are talking about production, or if you are talking about the multi-node cluster, then only master will be in one machine. Master is nothing but a one normal machine. Slaves are the other machines. So like this, if you start Hadoop like this in master machine, name node services, name node, job tracker, and second nodes will be start, and slave nodes, data node, and task tracker services will start. So how the Hadoop will recognize what is master, what is slaves? We will configure in the, we will have some configuration file. We will configure in the that conference. We need to configure in the configuration files. Next slides or next classes I will while discussing about the Hadoop installation, I will tell clearly what are the configuration files. I will tell. But just now now you need to remember Hadoop will have the master and slave architecture. In master will have the some services will start, and slaves will have the some data node and task tracker service. Actual data it will be stored in the data node. So in MapReduce side we will have the job tracker and task tracker is the daemon services. I will tell clearly about these things in the next while we discussing about the MapReduce. Okay, coming to HDFS distributed storage in the Hadoop. It will be concept of blocks. It will be stored into all Hadoop HDFS data. Internally it will store into local OS. Suppose if you have the Linux machine, so all HDFS data will be stored into Linux machine, but it will be stored as a blocks. I will show you how the blocks will store. Next class I will store where it will be stored. I will tell you. Next point is fault tolerance by replication. I think last demo or last class I will I told Hadoop will achieve the fault tolerance. Fault tolerance means data loss. So we will achieve the data loss by using the replication. So replication is nothing but a maintaining the multiple copies of the original data. So next slide I will explain. I will tell more details about the replication. One more is data pipeline. Then MapReduce. MapReduce is the distributed parallel processing, and it will be run into parallelly. It will run different machines. It will maintain the consistency. It will be it will process on the whatever we stored in the HDFS data. It will be on the top layer of the HDFS. So coming to what are the different Hadoop daemon processor. Once we started Hadoop, these are the process we'll learn. HDFS side we'll have the NameNode, data node, secondary NameNode. MapReduce for MapReduce side we'll have the job tracker and task tracker. Now you remember full this Hadoop cluster we will have the only one NameNode and one job tracker. But I think maybe you have some doubts regarding the single name node, but I will tell in next slides. I will explain clearly whether we need to have the single node or single name node or multi name nodes also possible. I will tell in the next slides. We have the different versions of the Hadoop. Hadoop 1 and Hadoop 2 is there, and Hadoop 1 we have the limitation of the single name node. Then they introduce the multi-name node in the Hadoop 2. I will explain next slides clearly at that point. But data node, coming to data node, original data it will be stored into data node. So each slave machine will have the data node. So that blocks, I'm telling the data will be split into blocks. These blocks it will be stored into data nodes. Next point is secondary name node. Secondary name node, why secondary name node means it is a kind of backup node for the name node. So basically in Hadoop 1, name node is a single point of failure. Once name node fail means everything will be, our cluster will be go down. So for maintaining the kind of backup thing, we will use the secondary name node. Next slides I will explain clearly about the secondary name node. I have one question from Saika. Okay, data node, we will store the original data in the data node, Saika. So next slide I will explain clearly. But now, what is data node means? If you store any data, it will be stored into it will be stored in data node. So each slave we will have the data node. So I'm telling if you store any file, it will be split into blocks. So these blocks it will be stored in data nodes. That is the thing. So next slide I will explain clearly data node. No Shaker. Data node will have only data. Name node only will have the metadata about the all the data nodes. Okay, coming to secondary node, NameNode, it is a kind of backup for the NameNode. Next slide, I will tell clearly about the NameNode and data node and secondary NameNode. Coming to MapReduce side, we'll have the job tracker and task tracker. Job tracker will have only one job tracker for the entire cluster. It will be in master, and we will have the different each machine will have the task tracker. Suppose originally if you submit any program to the Hadoop cluster, so job tracker will receive and it will be split into that each program we will call it as a job in the MapReduce. So that job will be split into different tasks. So so each mission will take some task, and it will be execute the task tracker will execute those tasks, original tasks. So main concept is, in master we will have the name node and job tracker. HDFS side will have the name node. MapReduce side will have the job tracker. Name node, what it will do means, suppose coming to production environment or coming to practical distributed thing. So name node won't, suppose if you want to store any data, first it will go to the name node. So name node will be give the what are the block locations. So it will be stored into different machines. So each machine will have the data node, and data node will be responsible for the storing the blocks. So data will be stored into blocks. Data nodes only having the information about the data. That data it will be stored as a blocks. Name node will have the information about, suppose if I store the 1 GB, suppose 1 GB of data, it will be split into different blocks. So each block information, so it will have the information about the which block will be stored into which machine, and how many blocks it will be split into how many blocks. So those details, those meta information, NameNode will maintain. Next slides, I think you will get more detail. That is the about the name node and data node and secondary name node. So okay, this is the original HDFS architecture. Like this will have. So name node, client want to store anything. First we will interact with the name node. Name node, it will be give the block based on the block size. It will be split into different blocks. So by default block size will be 64 MB. So each block it will be spread into machines. Blocks it will be spread into machine. So each machine will have the data nodes. So data nodes will have the original data about this thing. So first it will be split into blocks, then it will replicate into different machines. Next slides I will tell clearly those things. And also here we have the rack concept of rack awareness. Next slides I will explain clearly about the what is rack and those things. So generally basic idea about the rack means, generally data will be stored into data warehouse. So data warehouses, data machines are arranged in the racks. Racks means next to classes I will give some images for the full idea about the rack awareness, but it will be stored as a I think generally we will have the in-houses will have the racks now. So like that it will be how the machines are arranged in this some order. So that order will call as a racks, different rack. So I will tell more details about the rack in the next class. So name node will have the meta information like this. What is the how many replicas are there, coming to which file is stored into which machines, or which block is stored into which machine. That information will have the meta information is nothing but the information about the blocks and the files and the information. Metadata is information about the files and the blocks and directories. That information will have the name node. This is the architecture about the HDFS. Coming to here, one more, coming to this thing. So name node, how the name node and the data node will communicate. These name node and data node will communicate to the TCP/IP protocol. This is the network protocol. So name node, data node will send the some signals to the name node every few seconds. So that signals will call it as a heartbeats. So particular name node, suppose name node wants information about the whether particular data node is dead or particular data node is alive. So that for that communication, NameNode will send the signal to data node will send the signal to every few minutes. So based on those signals, or that signals we'll call it as heartbeats. So based on that heartbeats, NameNode will maintain information like a particular data node is dead or a particular data node is alive. Will have the information. Based on that information only, it will store the data. Suppose now here I mentioned 5 data nodes. If 5 data nodes are alive, so then if you want to store any data, NameNode will have the information about these data nodes. So if every data node is alive, then it will be spread the blocks across these 5 nodes. Suppose if any data node is failed means, then it will be spread data to only what are the live nodes are there. It will be spread to the only those nodes. So that is the concept of heartbeats. Coming to balancing, balancing is nothing but suppose if I have the 5 nodes, I stored from past few months I stored some data, and now after 5 months I'm going to add one more data. So that data, that mission or that data node is the new mission. So that won't have any data. But existing data nodes will have some data. But we don't have the balancing. Means some data will have some missions will have the more data, and newly added data is the don't have any data. So for balancing those things, we have the one concept of balancer. So next class I will tell about the more details about the balance. Balancing is nothing but balancing the data. For that we have the one command. If you run command, automatically it will balance. I will tell in next slides and next classes. Next concept is replication. Replication is nothing but maintaining the multiple copies of the original data. So by default, replication is the replication factor is 3. Next classes I will tell about the block size and the replication. So present you need to remember about the what is name node and what is data nodes, and how the name node and data node will communicate by using heartbeats. So these heartbeats is nothing but a TCP/IP and some network protocol signals. You need to remember those things. Okay, coming to here. So I have the one file. That file is split into 4 blocks. How the blocks will be split is based on the block size. So by default, block size is 64 MB. So we can decrease less than 64 MB. So that is the fixed size in the HDFS. So if we want, we can increase to more than 64 MB. Okay. So block size, if we want, we can increase multiples of 64 MB. And suppose if we want to increase, then next you need to increase to 128 MB. Like that, we can increase the block size. So next classes, I will tell you where we need to set this configuration. I will tell you. Present, remember, just blocks will be splitted based on the block size. So if we want, we can increase the block size. So when we need to increase the block size, I will tell in the next classes. So file will be split into 4 blocks. So based on the block size. So suppose here we have the 4 blocks. So B1 is stored into this machine, B2 is stored into here, B3 is stored into this machine, and B4 is stored into this machine. So now data is spread into 4 machines. Next concept is replication factor. So replication factor by default 3. If you want, we can decrease to 1 or 2. We can decrease. But in production, standard configuration is replication factor is 3. 3 means we have the multiple or 2 more copies of the original data. So why the replication factor means, if any data node is failed means, other copies will we will this name node will interact with the other copies. So here first we, based on the block size, we distributed the data. So B1, B2, B3 and B4 is the spread the data. So then B1 will be replicated to this data node and this data node. Two more copies is replicated. So B2, same time B2 is replicated to this machine and this machine. So here framework will take care. Framework will take care about the distributing the data. So our job is, we need to suppose if you we will have the some HDFS commands to store the data. So once if you run the that command, backend all these things will take care by the framework. We don't need to do anything. We need to only configure the what is the block size and what is the replication factor. So if we configure that one, automatically the data will be distributed based on the block size, and the data will be replicated based on the replication factor. So why the replication factor means, for the fault tolerance. Fault tolerance is nothing but a data lossing. So for avoiding the data lossing, we will use the replication factor. Suppose first machine is failed. Suppose first data node is failed means, in this data node will in this machine will have the three blocks, B1, B2, B3. So these three blocks will be in some other machine. B1 is there here, and B2 is in this machine, and B3 is in this machine. So if one data node is failed means, automatically if you, while any client or any user is interacting with the data, then automatically we will we will fetch the data from the other data node. So by using this replication factor, we will avoid the data loss. So this is the basic overview over the block size and replication factor. Coming slides I will tell clearly, and I will explain. I will have one presentation on this one. I will explain clearly. But till now, I hope you will understand about the block size and replication factor. If you have any doubts, next slides I will explain clearly. Then, if you have any doubts, we can discuss. That is the main thing. In HDFS block size and replication. So these things, everything it will be taken care by the framework. How the blocks will be splitted, how many blocks will be stored into first data node or first machine, or how many blocks will be stored into. That will be based on the load, and that will be based on the bandwidth or network. Based on that one only, framework will take care and it will store the data. Coming to MapReduce, I will just give brief idea about the MapReduce. MapReduce I will tell next classes. Once I finish everything about the HDFS, then I will tell. Coming to MapReduce, MapReduce is a parallel programming or parallel processing engine. So MapReduce will have the two main phases are two phases. Next we will have the different phases also will be there internally. I will tell you next. Main things are the two things: mapper and reducer. Mapper, what will do means, till now we discussed about the data is stored into different machines. Different machines it is stored into different machines. Now suppose if I want to run the one program, I want to count my words, number of words in the each file. So then what will do means, I have the data, some data is in some data node, some data it will be in some other machine. So each machine will have the some information about the single file. So now if I run the MapReduce program, mapper what will do means, each mapper will run on the particular machine. So now if I want to write the one logic counting the words, and if I execute it, then each mapper what will do means, it will each whatever the machine will have in single machine, that will be mapper will be run in that machine. And so we have the data in the different machines. So mappers will run parallelly on the different machines, and it will give the output, and these machines, these mappers output will be aggregate or will be clubbed into reducer, and reducer will give the final output as a HDFS file. So here we will have the reducer, we will have the one reducer, we will have the multiple reducers. Next classes I will tell you more details about the multiple reducers and the what is the mapper output and what is the reducer input, what is the reducer output. But present what is here main thing is mapper and reducer will have the key value pairs of data. So what is key, what is value, I will explain clearly in next class. Main thing is map reducer, we will have the main two phases, mapper phase and reducer phase. Mapper phase will parallelly, it will run in the different missions, and reducer also will have the one reducer and multiple reducer. If you have the multiple reducer, it will be run parallelly also. So mappers output we will aggregate. Basically what operations we will do in reducer means we will perform the sum, count, minimum, maximum, that aggregation functions, operations or transformations we will do in the reducer phase. So mapper what will do means we will process any kind of splitting the words, like that we will do in the mapper. This is the main basic idea about the map reduce. So this is one example about the map reduce. Suppose if I have the different words, so these words we will pass to the mapper. So it will split the words and it will be written the mapper output result are the key value pairs, word count, like that it will give. Next we will have the shuffle phase, and I will explain clearly in next class what is shuffle phase, what is shuffling. Then reducer we will our job is counting the words. So here it will be get the what are the common words, beer. So that we will count beer comma 2. So finally we will give as a beer comma 2, car comma 3. So final result it will be in HDFS. Like this we will process the data. So like this we will have the mapping and reduce. So next classes I will tell more details about this map reduce. Okay. Here coming to Hadoop 1.0, here I will give clarity about the how many name nodes will be there. I will give more clarity. So here we have the two kinds of here Hadoop we have the two versions. Initial starting about 1 year or 2 years back. 2 years back we have the only one name node. And the multiple data nodes will be data nodes will be there. Here one more concept is previously I told horizontal scalability. Horizontal scalability means if you want in horizontal scalability, if you want we can increase the multiple machines. But horizontal scalability in Hadoop 1.0, horizontal scalability it will be data node sites only we can have the multiple machines, but name node will be single name node. Suppose if name node fail means everything will be fail. We won't interact with the cluster, we won't interact with the HDFS data. So for avoiding that one, in Hadoop 2 they introduce the multi name node concept. So we'll have the one standby node and one active node and one standby node. Once the active node is down, standby node will come into picture. I will tell next slides I will explain about the Hadoop what is the basic idea about the Hadoop 2.0. I will explain. Hadoop 2.0 is the advanced concept. So most of the companies or most of the in production systems we will have the Hadoop 1.0 versions only. Hadoop 1 versions only will be there. So when we need the multiple name node means, suppose we have the large cluster, suppose we have the 500 nodes or 1000 nodes, that cases only we need to have the name node, more than one name node. Generally if you have the 10 node and 20 node cluster, one name node is enough. So basically why we need the multiple name nodes means, suppose if name node fail means we need the another name node will be take care, we need to take it. In that point of view, we need the multiple name nodes. So here basically this name node will have the more RAM. Why means now if you want to store anything, so it will store the data into memory. So current operations it will be stored into memory. So if you have the more data nodes, and if you are interacting with the more data, petabytes of data, so we need to interact with the lot of data in memory. So that's why we need more RAM in the name node. A data node we will store only data only. So in that point of view, we need more disk size rather than RAM. So that is the details about the thing. So in Hadoop 1.0, we'll have only one name node and one job tracker. HDFS side will have the one name node. MapReduce side will have the one job tracker, and each machine will have the different data nodes from HDFS side, and job tracker side, each machine will have the task tracker. So original name node will have the metadata about the this file system, about our file system, or information about the blocks, files, and directories. And data node will have the original data. So in Hadoop 2.0, I will explain the how they implemented the multi-name node concept. I will explain. So coming to secondary name node. Secondary name node is a kind of backup node. So I'm telling data node, if data node is failed means currently if you are suppose 10 users are trying to store something or trying to retrieve some data. So they are trying to create some files, or they are trying to the middle of that operation, this data node is failed means then everything suppose what are the operations are doing in the current operations will be we will lose. So for avoiding that one, secondary name node, what secondary name node will take care means secondary name node will contact with the name node and will fetch the data, what are the current transactions, it will be it will fetch, and it will club the old data with the current operations. So secondary name node will be only for only it will interact with only for our, it will be periodically it will interact with the name node. So that configuration we will do. We will configure for every half an hour we need to interact with the name node, or every 1 hour. That configuration we can specify. But here secondary name node means once name node is failed means some actually name node will have the two kinds of name node will have the store the meta information as a two kinds of files. One is the FS image, one is the edit logs. Next classes I will tell while doing practically, if I show you will get more idea, but if I tell here you will get confusion. But present what you need to remember means here we'll have the two kinds of files. One kind will be in one kind of data, it will be in disk. One kind of present operations it will be stored as some other files, edit logs. So if the name node fail means we will lose some data. For avoiding that one, we will use the secondary name node. Secondary name node is a it will interact with the name node, and it will fetch data, and it will club, and it will maintain as a one image. That image will call as a FS image. That details I will tell clearly, but you need to hear what we need to remember means secondary name nodes for every 1 hour it will interact with the name node, and it will fetch the data from the name node of the current operations, and it will merge to the one common image. So once name node failed means whatever the first 1 hour operations are there, it will be secondary name node. So once name node fail means we need to fetch the data from the secondary name node, and we need to copy to the name node, and again we need to run manually. This process is manually in the Hadoop 1, but Hadoop 2 this NameNode failure they implement as a automatic fashion. So but in Hadoop 1.0 this process is the manual process. If once NameNode is down means fetching the data from the second NameNode and restarting the NameNode is the manual process. That is about the Hadoop 1.0 and NameNode. Later next slides you will get the more details, more clarity on the remaining. Okay, till now this is the about Hadoop 1.0 and single name. So if you are talking about the Hadoop 1.0, we'll have the, for entire cluster we'll have the one name node and multiple data nodes. Each machine will have the data node. Coming to job tracker, coming to MapReduce part, we'll have the one job tracker for the entire cluster, and each task tracker will have the it will be in the each machine. That is the, and we'll have the one secondary name node. So these name node, secondary name node, job tracker, it will be in master. So there is no rule to it will be in master. So suppose if you install the Hadoop in single machine, everything it will be single machine. But coming to production, master will have the name node, secondary name node and job tracker, and every slave node will have the data nodes. So if you have the large cluster, if you want, you can maintain the name node in one machine and you can maintain in the job tracker in another machine. Like that also we can do. But basically in master we'll have the name node and job tracker and secondary name node. Based on the cluster and based on the burden, we can install in multiple each thing we will install in the different machines also, we can do it. But if we have I think we have the different modes of the Hadoop. I will tell in next class. We have the different pseudo distribution and the single node cluster and multi node cluster distributed mode. We have the different modes. I will tell in the next slides. So this is basic idea about the Hadoop 1.0. Next, coming to here we will get some more details about the name node. Here name node, I have the two different blocks A and C. So that information name node will have as a data node 1 have the block AC, data node 2 have the block AC. Like that, it will maintain the name node will maintain the information. File, suppose I have the one file is split in how many blocks. That blocks names are this one A comma C. So generally these blocks here I mentioned A comma A and C, but generally each block will have the one block ID. So unique block ID will have based on that block ID only that blocks will be identified. So splitting the blocks, assigning the block IDs, framework will take care that part. That part will take care by the framework. So this HDFS only will take care about the assigning the block unique block IDs and splitting the blocks. Everything will take care by the this name node. So here data node sends heartbeats to the name node, and every 10th heartbeats is a block report. So every few heartbeats, data node will send the report about the different blocks, how many blocks are there. So it will send the report to the name node. Based on that report only, name node will maintain the blocks information. So name node builds metadata from the block report. TCP means I think basically name node and data nodes will be different machines now. So those machines will be communicated by using the TCP protocol. Name node is down, HDFS is down. In 1.0, if name node is down, everything is down. But Hadoop 2.0, they achieved that one single name node point of view. So horizontal scalable in Hadoop 1.0, horizontal scalability it will be only data nodes part. It won't be in name node. So that horizontal scalability or high availability also they introduced in the Hadoop 2.0. So in Hadoop 1 versions, If NameNode is down, HDFS full HDFS will be down. That is the some more details about the NameNode. Coming to data node, each slave machine in our cluster will have the data node daemon. Here I am talking about the NameNode and data node. These are the daemon parts or daemon services. Once if we started HDFS, so basically NameNode it will be master. Master I am talking about it is one machine. Slaves are nothing but the other machines. So in this machine we will have these daemon parts, NameNode and data node. So coming to data node, each slave machine will have the data node daemon. So NameNode does not store the actual data of the file system. Data node is responsible for the storing data in the HDFS. So in production or in real time, we'll have the separate NameNode will be installed in separate machine. Data node will be installed in the separate machine. So NameNode will have only information. It won't store any data. But if we have installed everything in same machine, then in that case only we will have the NameNode also will have the will also have the data. So coming to in production or real time real distributed machine, we won't store the any information any data in the NameNode. But while practicing or while we're starting, that cases only, if you want, we can configure NameNode machine also as a data node. We can configure, but in real time we won't configure like that. We will NameNode will have only meta information. Data nodes only will have the original data. That is the second point, actual data of the files. Then data node send the information to the NameNode about the files and blocks stored in the node and responds to the NameNode for all the file system operations. So NameNode will send the information about the blocks to the NameNode. Sorry, data node will send the information to the NameNode. You can go through some other points. A client application can be talked directly. So if NameNodes will provide the block information, client will directly interact with the data nodes and it will store the data. Data node instance can talk each other, and which is what the data nodes also we can we'll have the communication between data nodes also. We'll have communication between data nodes for replication. If you want to for replication, each node will communicate with the other nodes. Coming to secondary NameNode, it is not a standby node. It will be a kind of backup kind of thing. Connects to the NameNode every hour, and it will kind of housekeeping or backup of NameNode metadata. Saved metadata can rebuild a NameNode. So this whatever the information in the secondary NameNode, based on that data, we can suppose NameNode is down, we can rebuild the NameNode. That is it. So I think it's been our so every 1 hour secondary NameNode will interact with the NameNode and will fetch the data secondary NameNode. So that is the concept of the secondary NameNode. Coming to job tracker and reduce task tracker, I will give more details about the next classes. Okay, we have the different modes of Hadoop. First, we have 3 modes of Hadoop. Hadoop can be run in 3 different modes. First mode is the standalone mode. Standalone is nothing. We will also call it as a local mode. This is the default mode of the Hadoop. So here we don't have the any HDFS kind of storage. Whatever you stored in the it will be stored as a normal Windows file or the normal Linux machine. It will be stored. We won't have any HDFS file blocks concept. We won't be in standalone mode. Mainly we will use for the debugging purpose. For this we don't have any configurations. Next mode is pseudo distribution mode. Pseudo distribution mode. For this mode we need to configure. We need some configurations. we need to be doing the configuration files. I will tell in the next class how we need to do the how we need to configure. And replication factor is 1. 1 means pseudo distribution mode is nothing but a single node cluster. So replication factor will be 1. And mainly we will use this mode for the if you want to test any code or if you want to test any commands, we will use the pseudo distribution mode. Then coming to fully distributed mode. Fully distributed mode is a production phase. So distribution mode is nothing but a we'll have the multiple machines in the cluster. We'll have the 20 node and 30 node, and we'll have the more nodes also based on the data. Large, I think Yahoo and Facebook, they are maintaining the large clusters. They are having the thousands of nodes in the cluster in full distribution mode. Basically, in present, other than that large companies, currently present companies, whatever they started, the startup companies or whatever they started out, they will maintain only 10 node or 20 node cluster. Later, based on data, they will increase the sizes. They will increase the cluster sizes. So this is about the distribute mode. A distribute mode, it will be data. It will be in distributed across the many nodes. Different nodes will have the used in master will be configured in some other machine. Data node will be configured in different machine. So what is the that is about the fully distribution mode. Coming to difference between the pseudo distributed mode and fully distributed mode. Whatever the code we tested in the pseudo distribution, without any changes, we can execute it in the production phase or the distributed mode. Those are the main details about the Hadoop. Then we have the different tools in the Hadoop ecosystem. I will explain the each tool clearly one by one. Once I will explain clearly one by one. First, I will go through HDFS MapReduce, these tools. So I think I think you almost I think you have some idea about the HDFS. Then later we'll go through the MapReduce and some other tools. The other tools we'll go by one. Next I have one presentation regarding this HDFS, how the data will be distributed. Then that presentation, if you have any doubts, we can discuss. Okay. Now I have the one master and the 4 slaves. Currently, if I consider assume my cluster have one master and 4 slave nodes. Master will have the name node. Slaves will have the data nodes. So now I want to store 1 GB data. Now I want to store 1 GB of file. So how it will be stored into HDFS, I will tell you. So first thing is that 1 GB data, how the 1 GB data need to be splitted. That will be based on the block size. So default block size is 64 MB. So based on this 64 MB, the 1 GB file will be split into different blocks. So our block size is 64 MB. So 1 GB file will be split into 16 blocks, B1, B2, like 16 blocks will be splitted. So these blocks, first it will be split into blocks, then these blocks will be stored into these things. So now 1 GB file, if you want to store 1 GB file, first we need to interact with the NameNode. NameNode, based on the block size, it will give the 16 block IDs. So based on these block IDs, these blocks it will be spread into different machines. So like this, if you see here, so some blocks B1, B4 will be stored into one machine, and B3, B16 will be stored into one machine. B3 will be stored here. B15 will be stored here. Here for understanding clearly, I missed here I mentioned only few blocks like this. B6, B7, B8 also like this. Those blocks also will be distributed. So first it will be distributed like this. So year 1 point is how many blocks will be stored into particular machine. So that will be based on the load and that will be based on bandwidth. So some machine will have the will store the 5 blocks. Some machine will be stored 1 block. Some machine will be stored in two blocks. Like that, it will be spread. It will be taken care by the framework. But what we need to understand means data will be spread into different machines. It will be that data will be stored as a blocks. That is the main concept in the HDFS. So now we store the all blocks into different machines. Then next step is replication. Replication 3 means now I copied only original data, I copied to all machines. Then replication factor is 3. Then what we will do means each block will be copied into some other 2 more machines. So B1 is copied to two other nodes, B2 is copied to 2 other nodes, same B3, B4, P15. Like this way, replication will happen backend. So first one copy will be write into all machines. Based on replication factor, it will be replicated into different machines. Now suppose I stored all the data. So now here almost all the these four machines are almost going to full. Now next I'm getting the few more data. Suppose from past 1 year I'm storing the data. Now almost all the four machines are full. Now I want to scale my cluster. How we can do means we can add one more machine to the existing cluster without disturbing anything, without restarting anything. We can add the one more machine and we can store the data further incoming data. We can store the future data, we can store into other machines. Like this we can that will be I have one question from the Jitendra. So what is the capacity of the each data node? That will be based on the incoming data. Suppose if you are getting the only terabytes of the data, then we can maintain the each data node as a 1 terabyte or something. So that will be based on the data, whatever data we are dealing. Suppose if you are dealing with the petabytes of data, we can configure nothing but data capacity is nothing but a we will assign the hard disk to the each machine. Suppose now if I have the 10 node cluster, now I am dealing with the only terabytes of data. Then each machine I can give the capacity as 1 terabyte. Then my total cluster capacity is 10 terabytes. So now I have the 10 nodes in the my cluster. So each node have the 1 terabytes. Then my total capacity of the cluster is 10 terabytes of capacity of the cluster. So here one point is now how much of data I can store into that 10 terabytes of capacity. I can store only 3.3 terabytes. Why means each suppose if I want to store the 1 terabytes of data, I need the capacity of 3 terabytes. Why means replication factor is 3. So in that cases, so based on the replication factor, we need to estimate the capacity. So if you want to store the 10 terabytes of 10 TBs of data, then we need to at least having the capacity of the 30 terabytes of capacity to our cluster. So each machine will have the 1 terabytes of hard disk or 2 terabytes of hard disk. That will be depend on the our machine's capacity or our data, how much data we will handle. I think I hope you understand, Jitin. Okay, thank you. This is the capacity of the basic idea about the capacity. So like this, we can extend the we can scale our cluster. So this is the main advantage about the HDFS. So if we are getting large volumes of data, we can scale our cluster without restarting or without doing any changes existing data or existing cluster. So here one more point is balancing. I told balancing. So if you see here, one machine, first machine will have the 4 blocks, some other machine will have 5 blocks. Like that, some machines will have the more data. This machine, slave machine, will newly added machines will have less data. So if you want to balance these data nodes, we will have the one concept called balancer. So for running the balancer, we will have the one commands in the HDFS. While telling about the HDFS commands, I will tell that balancer command. So based on that one, we can balance the cluster data also we can balance. Next, next thing is, so NameNode, what information it will have. So this file, file.txt, 1 GB file is split into 16 blocks. So each block, suppose if you take block 1, will be stored into what are the machines it is stored, what are the machines it is replicated. So if you coming to block 1 is replicated into data 1, and at the same time data node dn3. Dn means data node 3, and same time data node 4. If you go to block 16, block 16 is stored into replicated into 3 machines. Data node 2, block 16 is one copy, it is in the slave 2 or data node 2, and one more machine dn3, it will be stored into here. dn4, it is stored into here. So like this, this NameNode will maintain the information about these blocks and files, and what are the files are there, what are the directories are there, each file, how many blocks it is splitted, each block, what are the missions it is replicated. That whole information NameNode will maintain. That is the I think now you understand clearly about the what information it will be there in NameNode, what information it will be in data node. I hope you understood clearly. Yes, Shekhar, we can increase. I think starting previous slides itself, I told if you want, we can increase the block size. So here I will tell one more point. How we can decide the block size? Block size we need to decide based on the data. Suppose if you are only suppose if our cluster or if your project is dealing with only gigabytes of data, in that cases we will give the 64 MB. Suppose if your data is dealing, suppose if you take the Facebook, Yahoo, and those websites, they will have the more block size. So why they configure more block size means they will interact with the petabytes of data. So suppose if I want to store the petabytes of data, now if I given the 64 MB, I will generate lot of blocks. So suppose in this case, in our case, 1 GB file, for 1 GB file I given block size 64 MB. So I got the 16 blocks. But if I have the 1 terabytes of data, I will get the 1024 into 16. Total we will got the lot of blocks. I think more like 16,000 blocks are we will get. So 1 GB file we will get the 16 blocks. Then 1000 blocks we will get the 16,000 blocks. So means suppose if I have the petabytes of data, I will get the more blocks. So maintaining these blocks information burden to the NameNode. So in that cases, if we increase the block size to suppose 128 MB, we will decrease the number of blocks, and also we will decrease the meta information of in the NameNode. That is the concept of the block size. So if you are interacting with the more data, we need to configure the block size more. If you are interacting with the less data, we can give as 64 MB. By default, we can give the 64 MB. So suppose in our concept, 1 GB file, suppose if I give the block size 64 MB, 1 GB file is split into 16 blocks. Suppose if I configure block size is 128 MB, this 1 GB file will be split into 8 blocks. So each block will have the 128 MB of data. That is the concept. Blocks. We can't give minimum is the 64 MB. We can't decrease less than 64 MB. Suppose in configuration files, if you configure less than 64 MB, framework will give configuration errors. I think if you want to, if you configure less than 64 MB and if you started the HDFS, it will throw some errors. So we can't configure less than 64 MB. But replication factor we can configure to 1 also. Minimum is 1. We can decrease to 1. Minimum is 1, but standard production standard thing is replication factor is 3. If you want increase the if you want more security or more on the data, we can increase more than 3 also. We can increase. That is the main overview about the what is NameNode, what is data node, what NameNode will have the information. One more concept is fault tolerance. I told now. Suppose here one machine is failed. Suppose slave 1 is failed, then automatically what are the blocks is there? V1 is replicating to some other machine. Suppose anyone is interacting with the any file. Suppose one machine is down, means automatically that user will be fetch the data from the other nodes. So in that cases we won't get the data loss won't be there in the this cluster. That is the concept of the replication. So by using replication we can achieve the fault tolerance. So these are the main idea about the HDFS concepts. What is block size, what is replication, and everything. Next, this is the main points about the HDFS. Next class, tomorrow class, I will start the how we can install the Hadoop. What are the how we can download and how we can what are the configuration files. I will start. I will tell about single node, how we can do the single node cluster. I will tell you tomorrow. I will tell you. Then once we configure single node and multi node. Once we single node and first I will tell the single node, then I will tell multi node, then I will explain the HDFS command. Once HDFS is completed, then we will go through the map reduce. So next 2 or 3 classes I will explain. I will tell about how we can install the single node cluster, multi node cluster. I will tell those details, and we will also practice the HDFS. Okay, 1 minute. Other thing about next classes. I have one question from Jitendra. What happens to the data on the data node after task completed? Data it will be there in the data nodes, Jitendra. Task completion also it will be there. So HDFS is the data storage. So we will store the suppose we have the any application or any kind of thing, continuously we will store data. That data will be permanently we will store that data. Whenever if you want to, we don't want the data, then only we will delete manually. Up to that point the data will be there. Suppose if you want to run programs on that data, then we will MapReduce will come into picture. We will run the programs on this data, then job tracker and task tracker will come into picture. Once task is completed, also data will be there. Data will be there. HDFS we will store the data permanently. If this data will be stored, we can store years also. We can store. If your application want to survive in 10 years, 20 years, the 10 years, 20 years, we will store the HDFS data. Coming to Google or Yahoo, we won't the data won't be deleted after task. it will be permanent data. That is answer from my side to your question. Okay, thank you, Jitendra. That is about the HDFS, and I think you understand. I think clearly about the HDFS. Then we will go through about the next thing. If you have any questions, you can ask me. I will give answers. Okay, thank you. That's all for the today class. We will go through the installation about the next class.